And here it is, another question from Seba 2018, Seba Board Hslc 2018 for 3 marks. It just says, find the roots of the following quadratic equation, 2x squared minus twice of root 2x plus 1 is equal to 0. Usually whenever you begin a quadratic equation of this sort, I would always recommend that you identify its standard form first in this manner. So this is what I wrote here. If you would see that the equation is of the form ax squared plus bx plus c is equal to 0. Here a is equal to 2, b is equal to 2 root 2, a square root of 2, and c is equal to 1. Identifying the coefficients as well as the constant. Then you declare what is the discriminant. Discriminant d is equal to b squared minus 4ac, and I have written it this way so that you would be able to identify it of how it became finally 8 there where you had the square roots. So it would be 2 into root 2 whole thing square, then you square the minus 2 here and the root 2 you square here, then minus into minus becomes a plus, then you have a 4, and then root 2 into root 2 becomes a 2, and then 8 minus 8 will give you 0, and the equation will have 2 equal roots because the discriminant is equal to 0. Then you go ahead and use the quadratic formula, and here is your quadratic formula, and you insert your minus b, which is this one here, which is minus of minus 2 into the square root of 2 plus root 0, which is the 0 is this one, which is your discriminant, so that's why we put it there. And then when you do this, you will get upon 2 into 2, which is 4, and then you get here 2 root 2, which you can cancel. Alright? So when you get 2 root 2, which you can cancel, you get root 2 upon 2. After you cancel this one and this one, what remains is 2. And here what remains is 2 root 2. Then you rationalize, or putting conjugates. How do you get a conjugate? Is that you multiply the same thing with the same thing. So root 2 into root 2 on the numerator would have to be kept as root 2 on the denominator side also. So when you do this, root 2 into root 2, you get 2, and 2 root square root of 2 is this one. So here what happens is that you would get 2 and 2 cancels, so that will be this 2 and 2 cancels, and that will leave you with 1 upon root 2, and the roots are x is equal to 1 upon root 2 or x is equal to 1 upon root 2. And that is your answer. Very quick way of resolving the solution and having the equal roots.